Hello and welcome to Astronomy Daily, your daily dose of cosmic news and celestial happenings. I'm Anna, your guide through the cosmos. Today we've got a stellar lineup of space stories that will take us from nearby asteroids to the mysteries of distant galaxies. We'll explore NASA's Lucy spacecraft and its fascinating encounter with the uniquely shaped asteroid Donaldjohanson, dive into the surprising discovery of a potential diamond layer inside Mercury, and catch up on this week's busy launch schedule. We'll also look at Amazon's Project Kuiper as it prepares for a milestone launch, and examine an ambitious plan to place satellites around the moon to detect radio signals from the universe's ancient dark ages. So buckle up for a journey across our solar system and beyond as we explore the latest developments in space exploration and astronomical discovery. Let's get started. NASA's Lucy spacecraft has just completed its second asteroid encounter, giving us an unprecedented view of asteroid Donaldjohanson from approximately 600 miles away. The images, which started arriving on April 20th, 2025, have already revealed some fascinating details about this cosmic object that formed roughly 150 million years ago. Scientists had previously observed large brightness variations from Donaldjohanson over a 10-day period, suggesting it might be an elongated body. But when Lucy's first images came in, they showed something even more intriguing. What appears to be a contact binary, essentially two smaller bodies that collided and stuck together. What's particularly striking about Donaldjohanson is the unusual shape of the narrow neck connecting its two lobes. Mission scientists describe it as looking like two nested ice cream cones. This unique structure wasn't what the team expected and adds another puzzle piece to our understanding of how asteroids form and evolve. Preliminary analysis from Lucy's LORRI imager indicates Donaldjohanson is larger than originally estimated, about 5 miles long and 2 miles wide at its widest point. The full asteroid wasn't initially visible in the high-resolution images because it's actually larger than the imager's field of view. The team expects to download the complete dataset over the coming week, which should provide a more comprehensive picture of the asteroid's shape. Hal Levison, Lucy's principal investigator, notes that asteroid Donaldjohanson has strikingly complicated geology. As we study the complex structures in detail, they will reveal important information about the building blocks and collisional processes that form the planets in our solar system. While Donaldjohanson isn't a primary target for the Lucy mission, this flyby served as a full dress rehearsal for future encounters. The spacecraft conducted a series of dense observations to maximize data collection. In addition to images, Lucy's other scientific instruments, the LaRalph Color Imager and Infrared Spectrometer, along with the LTS Thermal Infrared Spectrometer, collected data that will be analyzed in the coming weeks. Lucy will spend most of the remainder of 2025 traveling through the main asteroid belt before reaching its first main target, the Jupiter Trojan asteroid Eurybates, in August 2027. The spacecraft's ultimate mission is to study these Trojan asteroids which orbit the Sun in the same path as Jupiter and are considered time capsules from the early solar system. As Tom Statler, program scientist for Lucy at NASA headquarters, put it, these early images of Donaldjohanson are again showing the tremendous capabilities of the Lucy spacecraft as an engine of discovery. The potential to really open a new window into the history of our solar system when Lucy gets to the Trojan asteroids is immense. Let's get a little update on Mercury and a finding that might make the planet a lot more attractive to some people. Mercury may be the closest planet to the Sun and often overlooked in our cosmic neighborhood. But scientists have recently discovered something truly dazzling about this scorched world. New research suggests that Mercury may be hiding a diamond layer approximately 10 miles thick beneath its surface. This extraordinary finding comes from analyzing data collected by NASA's Messenger spacecraft, which mapped Mercury in detail during its mission. The spacecraft detected graphite patches scattered across Mercury's crust, indicating the planet once had a magma ocean incredibly rich in carbon content, higher than any other rocky world in our solar system. When this ancient magma ocean cooled, lighter carbon floated upward, creating the dark graphite patches visible on the surface. Meanwhile, denser materials, including carbon, sank inward. According to researchers from China and Belgium, led by Dr. Yanhao Lin, this heavier carbon descended alongside sinking metal and recrystallized into diamond under immense pressure. To test this theory, scientists recreated Mercury's interior conditions in a laboratory. They used a specialized press to squeeze synthetic mantle rock to 7 gigapascals, roughly 7 times the pressure found at the bottom of the Mariana Trench, while heating it to nearly 3,600 degrees Fahrenheit. Their experiments confirmed that at Mercury's core mantle boundary, with its unique pressure and temperature conditions, carbon transforms from graphite into diamond. These diamonds would theoretically form a sparkling shell up to 11 miles thick around the planet's metallic core. This diamond layer may also explain another Mercury mystery, its surprisingly strong magnetic field. For a planet only slightly wider than the continental United States, Mercury maintains a robust magnetic field that requires heat to flow out of the core. Diamond, being an excellent thermal conductor, would efficiently funnel this energy upward, helping to maintain the magnetic dynamo that generates the field. Unlike Earth, Mars, and Venus, which lost most of their carbon to space or locked it in carbonates, Mercury appears to have hoarded its carbon, first as floating graphite and then as diamond, sinking to great depths. While we can't directly observe Mercury's interior, the European-Japanese Bepi-Colombo mission currently en route to the planet may provide confirmation when it arrives in 2030. Its instruments will refine gravity maps and look for twists in Mercury's magnetic field that could reveal the presence of this superconductive diamond layer. This discovery isn't about finding gemstones for jewelry, it's about understanding planetary evolution. Carbon's behavior shapes a planet's heat flow, crust composition, and even its magnetic field. By tracing carbon's journey through Mercury, scientists can refine models that apply to worlds throughout our universe, including those orbiting distant stars. What initially appears as just a scorched ball of rock is revealing exotic physics and hidden secrets that are absolutely worth exploring further. Time to take a look at this week's launch calendar. This week is shaping up to be a busy one for space launches, with missions taking off from around the globe. Let's start with China's upcoming crewed mission to their Tiangong space station. On Thursday, April 24th, the Changzheng 2F rocket will lift off from the Jiuquan Satellite Launch Center, carrying 3 taikonauts on the Shenzhou 20 mission. This marks China's 15th crewed spaceflight and the 9th crew transportation mission to their space station. While the 3 crew members were selected back in February, China typically doesn't officially announce their names until about a day before launch. The Shenzhou 20 crew will replace the current occupants of the station, Song Lingdong, Kai Shuji, and Wang Haozi, who have spent the past 6 months in orbit. Once a formal handover ceremony is completed, the Shenzhou 19 crew will return to Earth. SpaceX is having a particularly active week with 3 Falcon 9 launches on their manifest. The first is their 3rd bandwagon rideshare mission, scheduled for Monday evening from Cape Canaveral. Bandwagon missions carry multiple smaller satellites to mid-inclination low Earth orbits, complementing SpaceX's transporter missions, which primarily target sun-synchronous orbits. Notable payloads on this flight include VAST's Haven Demo Technology Demonstrator weighing approximately 500 kilograms, Atmos Space Cargo's Phoenix 1 prototype re-entry capsule, which will test an innovative inflatable heat shield, and several Earth observation satellites from Hawkeye 360. The Falcon 9 booster supporting this mission, B-1090, will be making its 3rd flight and is scheduled to return for a landing at Cape Canaveral's Landing Zone 2. SpaceX has 2 more Starlink launches planned later in the week, one from Florida on Thursday evening carrying satellites for Starlink Group 6, 74, and another from Vandenberg in California on Friday afternoon for Starlink Group 11, 9. These launches continue the rapid expansion of SpaceX's Internet mega constellation, which now connects over 5 million users across 125 countries. Meanwhile, Firefly Aerospace is preparing to launch its Alpha rocket from Vandenberg Space Force Base on Sunday. This mission, playfully dubbed Message in a Booster, will carry Lockheed Martin's LM-400 technology demonstration satellite. This marks the 6th launch of Firefly's Alpha rocket and the 2nd flight in a multi-launch agreement with Lockheed Martin that could span up to 25 launches over the next 5 years. The LM-400 is Lockheed's new mid-size satellite bus designed for versatility. It can accommodate various missions, including remote sensing, communications, imaging, and radar operations. This Pathfinder mission will help prove the technology in orbit before it's used for customer missions. All these launches underscore the growing cadence and diversity of space missions, from crewed flights and satellite deployments to technology demonstrations that push the boundaries of what's possible beyond Earth. Speaking of launches, after multiple delays, we finally have a new launch date for Amazon's Project Kuiper Internet satellite constellation. United Launch Alliance announced that the first batch of 27 operational Kuiper satellites will lift off aboard an Atlas V rocket on April 28th at 7 p.m. Eastern Time from Cape Canaveral Space Force Station in Florida. ULA has set aside a 2-hour launch window for this mission. This launch, designated Kuiper 1, marks a significant milestone as the first of a planned 83 launches needed to deploy Amazon's ambitious broadband constellation. The company aims to place more than 3,200 satellites in low Earth orbit to provide global high-speed internet coverage. These satellites aren't Amazon's first space hardware. The company successfully launched 2 prototype Kuiper satellites last year to validate the technology and pave the way for this operational fleet. The upcoming mission will utilize ULA's Atlas V rocket in its most powerful 551 configuration, featuring 5 solid rocket boosters. This launch also represents a historic moment for ULA as it marks the 250th flight of a Centaur upper stage atop an Atlas rocket. The launch was originally scheduled for early April, but was postponed due to unfavorable weather conditions. When asked about subsequent delays, ULA CEO Tori Bruno simply cited range availability as the limiting factor, suggesting congestion in the Eastern Range launch schedule managed by the U.S. Space Force. While Amazon has contracted ULA for 7 more Kuiper missions on Atlas V rockets, the company is diversifying its launch providers for the remainder of its constellation. Future Kuiper satellites will ride on ULA's newer Vulcan Centaur rocket, Arianespace's Ariane 6, Blue Origin's New Glenn, and even SpaceX's Falcon 9. Despite SpaceX being a direct competitor with its own Starlink internet constellation, Amazon's Kuiper satellites will operate at slightly higher altitudes than Starlink, with the fleet distributed across 98 orbital planes in 3 layers at altitudes of 590, 610, and 630 kilometers. This launch begins a new chapter not just for Amazon, but for the growing commercial space industry as competition in the satellite internet market continues to heat up. Finally, for today. In an exciting development for lunar exploration and cosmology, the Italian Space Agency has selected European company Blue Skies Space to build a revolutionary satellite fleet that will orbit the Moon. The project, named Radio Luna, will be developed in partnership with OHB Italia and aims to use the unique radio environment of the lunar far side to detect signals from the early universe that are impossible to capture from Earth. The mission targets what astronomers call the dark ages of the universe, the period before the first stars formed, when the cosmos was filled with neutral hydrogen gas. These ancient radio signals hold valuable information about the universe's earliest structure, but they're exceptionally faint and difficult to detect amid Earth's cacophony of human-made radio interference. The far side of the Moon offers a perfect radio quiet zone, shielded from Earth's electromagnetic noise. If successful, Radio Luna's small satellite constellation could provide unprecedented insights into the universe's formative period, essentially creating a map of cosmic dawn. We are grateful to the Italian Space Agency for funding this activity with our project partner, OHB Italia, to explore novel ways of delivering exciting science, said Marcel Tessigny, Blue Sky's co-founder and CEO. He noted that the project aligns with broader international efforts to develop lunar infrastructure through programs like ESA Moonlight and NASA Artemis. What makes Radio Luna particularly innovative is its approach to spacecraft design. Rather than building expensive custom satellites, the network will utilize small CubeSats equipped with commercial off-the-shelf components. This strategy emphasizes simplicity and cost-effectiveness, potentially creating a template for future scientific missions. Roberto Assetti, managing director at OHB Italia, described the project as a challenge where scientific ambition meets engineering pragmatism, highlighting their pride in contributing to an observatory that could open new frontiers in our understanding of the early universe. While details on funding and launch timelines haven't been disclosed, Radio Luna represents an intriguing example of how the burgeoning lunar economy might support fundamental scientific research. By leveraging the unique properties of the lunar environment, these small satellites could help unlock some of the biggest mysteries about our cosmic origins. And that brings us to a close for this episode. What an incredible journey through space we've had today. From Lucy's close encounter with the oddly shaped asteroid Donaldjohanson to the stunning possibility of a diamond layer deep within Mercury. We've explored the packed launch schedule ahead, with China sending taikonauts to their space station, SpaceX's multiple missions, and Firefly preparing for their technology demonstration flight. We also learned about Amazon's Project Kuiper finally getting its launch date after several delays, with those first 27 internet satellites ready to begin building their orbital constellation. And of course, the fascinating Radio Luna project that aims to use the moon's far side as a quiet zone to listen for whispers from the universe's dark ages. Space exploration continues to surprise and inspire us, revealing new secrets about our solar system and beyond with each mission. These discoveries not only expand our scientific knowledge, but remind us of the incredible ingenuity of human exploration. This has been Astronomy Daily with me, Anna. I want to thank you for joining me on this cosmic journey today. If you're hungry for more space news, visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and catch up on all the latest space and astronomy news with our constantly updating newsfeed. You'll also find all our back episodes there ready for your listening pleasure. Don't forget to follow us on social media too. Just search for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Instagram, Tumblr, and TikTok. Until next time, keep looking up at the stars, and I'll see you for our next exploration of the cosmos.